Hey folks, I am going to be giving you guys a brief rundown of the different families in the periodic table. Family is another word for group on the periodic table. We know that those are the columns. And I know that you guys studied these when you did your research project. You should have done two of these and gotten some characteristics of those two that you were assigned. But just to kind of fill in the gaps for our knowledge here, I'm going to briefly go a run through of the different families on the periodic table. So our first family is going to be the alkali metals, our first group, I'll say. So these are called our group 1 metals, and that means they're in the first column on our periodic table to the far left. We do not include hydrogen in this column. We know that hydrogen, based on the coloring of your periodic table, you should have this in front of you or somewhere accessible. Hydrogen is going to be a non-metal, so this is not going to include hydrogen. Our group 1 metals are shiny, malleable, and ductile. Another word that I want you to think of for shiny is lustrous. Lustrous has the same meaning as shiny. Malleable and ductile basically just mean if you were to kind of feel one of these metals, you'd be able to bend it and maybe stretch it and without it actually breaking. Ductile specifically is going to mean you could pull it into like long strips, kind of like wire, and you would be able to do that without these metals breaking. These are going to be softer than other metals, so that helps them be so malleable and ductile. And they're really good conductors of heat and electricity. And these are the most reactive of all metals. So I've talked about this a little bit in class, but if you were to drop, say, some lithium, that's this one here, or some sodium or potassium into water, you would probably get some sort of an explosion. So these are the most reactive of all of the metals. And that's because they have one valence electron. We're going to talk about what valence electrons means later in this week, but a valence electron means the outermost electron that it's carrying in that kind of electron cloud that surrounds the nucleus. If they have one valence electron, they have one that's like really the farthest out. And they can give that up really easily, and that's what makes them so reactive. So that's where these are on your periodic table. Our second group is the alkaline earth metals. So these are our group 2 metals. They're in the second column here. So these are still shiny or lustrous, malleable, and ductile. They're very reactive, but not quite as much as group 1. And that's because they have 2 valence electrons now. So they're starting to fill up that outermost kind of layer of electrons. We call it a shell. And they give up, the alkaline earth metals give up those 2 valence electrons fairly easily, but not quite as easily as our group 1 metals are going to give up their 1 valence electron. So these are pretty reactive, but not quite as much as our group 1 metals. So our third group actually is a very large block of the periodic table. So that's going to comprise groups 3 through 12. So it's a bunch of different columns. And these are our transition metals. Transition metals are still metal, so they're still lustrous or shiny, malleable, and ductile. And they often form really colorful compounds with other elements. So remember, a compound is when you combine different elements together, and that compound can have different physical and chemical properties from the elements themselves. And so specifically our transition metals are going to form really colorful compounds. Transition metals also can have a different number of valence electrons. So iron specifically could have like 2 or 3 valence electrons, depending on the atom of iron that you're looking at. So that's where these transition metals are. I'm going to mention lanthanides and actinides now. I don't cover those in this particular slideshow, but our lanthanides, remember, and our actinides are down on the bottom. And those are going to comprise these long periods or rows of the periodic table. And they're considered metals, so they have a lot of the same characteristics of metals, of being lustrous and malleable and ductile. Specifically, the actinides are all radioactive, and only the first couple are actually going to be found in nature. So most of the ones down here on the very bottom row are going to be things that have to be made in the lab. Next is our metalloid group. So the metalloids, remember, kind of span this intermediate space between your metals and nonmetals. That's going to be on the stair step portion of your periodic table. And these, because they're in between metals and nonmetals, are going to have intermediate properties between metals and nonmetals. So some things about them is they're often pretty lustrous. That's what lustrous looks like spelled out. It just means shiny. They're often lustrous like metals, and they're usually more brittle than metals, which means that they're not as malleable and they can actually break. And they also are usually less conductive than metals. So that's kind of, they don't transmit electricity or heat quite as well as some of our metals do. So that's where our metalloids are on this group here, on this periodic table. Our black is the metalloids. Our next one is halogens. So we're going to the far right of the periodic table now and one column in, or one group in. So these are group 17. If you look at the heading of this column, this is the 17th column. and they're called halogens. These are very reactive again. So on either end of our periodic table is where we get the most reactive things. And they have 7 valence electrons. So they're almost full in that outer shell. And again, we'll talk about valence electrons later. But essentially, any element can hold 8 electrons in its outermost shell. And so they have 7, so they're almost there. And they like to take an electron from a metal in order to form what we call an ionic compound. Basically, that's just a salt. So maybe you know that sodium chloride is NaCl. And what happens in sodium chloride, that's just table salt, by the way. What happens with sodium chloride is your chloride takes actually an electron from sodium and they kind of combine close to each other. They get close to each other that way. And that's how salt is formed. These halogens are going to have really distinctive colors, which can help you tell them apart from other things. And the most chemically reactive of all the elements is actually going to be your halogen in period 1. So period goes across and group goes down. So your halogen in period 1 is fluorine, and that's going to be the most reactive of any element. So that's where our halogens are located. And last but not least is our noble gases. So these are to the far right of your periodic table, and it's going to start with helium in our first period. These are group 18, they're nonmetals as well, and they exist as isolated atoms. That means that they do not like to combine with other things, and they don't form compounds. So they actually just hang out by themselves. And the reason is that they have filled up that outer shell of valence electrons. So I said that any particular element can have 8 valence electrons in the outermost shell. That's as many as they can hold. And these noble gases have all 8 of those valence electrons filled, so they don't like to do any exchange. They're very happy having that outer shell filled. They don't want to take anybody's electrons, and they don't want to give up any electrons. So these are really stable gases. And they produce really distinctive glows when you pass electricity through them. So specifically, you might know of neon being something that glows. We use that in a lot of signs that you can see if you're out walking around at night. You might see some neon signs. And it starts to glow because they're passing electricity through that gas, and that's what gets that distinctive neon glow. So that's where these noble gases are. And then if we fill up our whole periodic table, oh, sorry, not the lanthanides and actinides. I meant to put that in there. But we've got our other metals in yellow here. Those have pretty similar characteristics to metals. And then we've got our other non-metals right here, plus our hydrogen gas. So I'm going to switch gears a little bit, and I'm going to pause this video and pick it back up. I promise I'll keep the whole thing less than 10 minutes though. Okay, so I just wanted to help you orient on your periodic table and remind you of some important things on the periodic table that you can find that might help you be able to do your first assignment for today. So this is just an image of a periodic table. This is the coloring option that people had who were fully virtual. So if you're fully virtual and you did this, you might recognize this. If you were somebody who did the coloring of your periodic table in person, then you're going to need that to complete your assignment. So just things to remember. Across the top, you can see these little numbers on the very top of all of your different columns. Those are the group numbers. And across the side, we can see our different row numbers. Those are the period numbers. So when you're asked for what group or period an element is, that's where you're going to look. If you're asked for an atomic number, you're going to look kind of on either the top of each of our squares or on the upper left of each of your squares, and that's going to tell you the atomic number. So for instance, our atomic number of zinc right here is going to be 30. So we can see that 30 right there. Other things to keep a lookout for are just knowing your different groups and what they're called. So this should be color-coded for you. But we've got our alkali metals first, then our alkaline earth metals. We've got all of our transition metals here. And so on and so forth. So that's going to help you with that. You are asked about things that are lustrous. So remember that lustrous means shiny, and that's going to be all of our metals. Our non-metals are going to be not shiny, and those are what are going to react with our metals to create things called salts. And I think the last thing that you might need to know is that for something to have similar properties as something else, it's going to be in the same group as that thing. And we're going to look down the column to determine that. So for instance, all of our alkali metals are going to have very similar properties to each other, and they're located in the same column or group. Same thing with alkaline earth metals, very similar to each other, and they're going to be located in the same column or group. Oh, and one more thing is that you can find the mass of a particular element. That's going to be the decimal number down at the bottom of the particular square. So hopefully this helps, and I will see you tomorrow.